Okay, boys, so we're going to go through some word problems now, and the hardest part of these is drawing the diagrams. So I'm going to go through from step by step how to draw the diagrams. Before I do start though, there is something that I meant to say on the last video. If you're getting a whole bunch of wrong answers so far, you might want to check your calculator. So right up the top of it, right up the top on the actual screen, so right up the top here, where I'm pointing, there should be D, capital D for degrees. If that says anything else, like if it says R or G, you're in the wrong mode. Okay, so that means that all your answers are going to be wrong on this. So the way you make sure you're okay with this is to press. You want to look at the setup button there. So we've got to press shift, mode or setup. And then when you look at your screen there, you want the one that says DEG for degrees. So if you are in the wrong one, like R for RAD, which you don't use till year 11 and 12, or G for GRA, then somebody's been playing with your calculator and you've got it in the wrong mode. So to get it back to degrees, you just press the 3 now for degrees, and that'll make sure that up the top of your screen you've got that D here. Because that means that every angle that you're putting in your calculator has to be in degrees, and that's what that's actually saying. Okay, even with the degrees in minutes, the first thing that it is degrees. Okay, so getting started here with our diagrams, we've got triangle ABC is right angled at B. So that means we've got a right angled triangle, and it's right angled at B. Then it says AC equals 14.8 metres. Well, you go, well, I don't have anything else on there. But remember they told you it's triangle ABC. You've got the B there. The A and the C, it doesn't matter where they go, as long as they're there. So I'm going to put the A here, the C here, and now we'll do the rest of it. AC equals 14.8 metres. And angle C equals 56 degrees. And that's the diagram. Now they're asking you to find the length of side AB, which is this one. So we're just going to label that with an X. And now we can start our question. So we're going to label this side here, that's the hypotenuse. And we're going to label this one down here, which is opposite that angle. And we're going to be using sine. So sine theta equals O over H. Sine 56 degrees for our angle equals X over 14.8. Then remember we're getting rid of 14.8. So instead of dividing by 14.8, you'll come to the other side and times by 14.8. Put it in your calculator, and they want 1 decimal place. So make sure you round off to the 1 decimal place and put M for metres on the end of your side length. Okay, now coming over to the next one. In this one, a tree casts a shadow 20 metres long. If the sun's rays meet the ground at 25 degrees, find the height of the tree. You've got to draw these diagrams right if you want to get the question right. They're all going to be right angled triangles because that's what the topic we're on. Now, it's a tree. We assume the trees which stand vertical are at right angles to the ground. So here's your tree. All right? Goes up that high, so whatever. Okay? So your tree is the vertical thing. Now, it casts a shadow 20 metres long. Shadows are on the ground. So here's your shadow down there. Okay? And now it says, if the sun's rays meet the ground at 25 degrees. Now, what actually causes a shadow is when you have your sun, one of those rays will hit the top of the tree, which is here, and continue onto the ground, and that's what forms the length of the shadow. Okay, so that's what's happening. Now it says the sun's rays, here's your ray, meets the ground at 25 degrees. So here's the sun's ray, here's the ground, it's the angle between them. That's 25 degrees. Okay, now we're going to label our sides. We're trying to find the height of the tree here. So we might call it H for height. So we've got the opposite side to our angle, we've got the adjacent side to our angle, and we're going to be using tan. So tan theta equals O over A, tan 25 degrees equals H over 20. Get rid of your divided by 20 here. Come to the other side and times by the 20. Now get your answer off your calculator, which will be that big long decimal. Now it says correct to the nearest centimetre, but this answer will be in metres because that's what that was in. Now to go to the nearest centimetre, you can go converting to centimetres and do it that way, but if you can remember it, this is quicker. So because it's a centimetre, right, there's 100 centimetres in a metre, you can just put a 1 under the decimal point and 100, 0, next to it, and that tells you where you're rounding to. So draw your line, look at your next digit, that's 5 or more, so this is going to go up by 1, and you can give your answer as 9.33 metres. That is still correct to the nearest centimetre. Or you can convert that to centimetres and give 933 centimetres. Both of these answers are correct. Okay, looking at the next one. We have a ladder placed against a pole. We start with a right angle triangle. A ladder, there it is leaning against a pole. Now, it's a 6 metre ladder, so you can put 6 metres here. If the ladder makes an angle of 17 degrees with the pole, so here's your ladder, here's your pole, the angle of 17 degrees is between them, and the question is, how far up the pole does the ladder reach? So we want to know this, so we're going to call that X. And now we label our sides. This is your hypotenuse. This is your adjacent side. A and H means we're using cos. So it's cos theta equals A over H. Put your angle in. Cos 17 degrees equals X over 6. Get rid of your 6 by coming over here and timesing by 6. Use your calculator to get your answer. Now, our answer will be in metres because this is in metres. They've asked for nearest millimetre. Milli is 1,000. So again, do a 1 under the decimal point and 3 zeros for the 1,000 under it, and that tells you where you're rounding off to. The next digit, if you circle it, is an 8. That's 5 or more. So this will go up by 1 to 8. And your answer will be 5.738 metres, or if you really want to convert it to millimetres, 5,738 millimetres. Okay, the next question. A boat is anchored. So we've got to draw our right angle triangle. A boat is anchored by a rope 5.5 metres long. So here's your water level. Here is your boat. Okay, and if you've ever seen a boat with its anchor, boats are not going to sit directly above an anchor because the tide and the water is moving. So there's your boat. I should have drawn it a bit further over, but let's just say it finishes there. Okay, and there's the chain to your anchor. The anchor sits on the bottom of the sea or the river that it's in. So it's sitting on the ground, the boat's sitting on the surface of the water, and this is your anchor rope here. That's 5.5 metres long. The anchor rope makes an angle of 23 degrees with the vertical. There's the anchor rope. There's the vertical. That's the angle they're talking about between them. 23 degrees. Calculate the depth of the water here's the depth of the water. So we're going to call that D for depth. And that's what we're trying to find. So if we label our sides, this is your hypotenuse, this is your adjacent side. So we're using cos theta equals A over H. Put your angle in, cos 23 degrees equals D over 5.5. Get rid of your 5.5 by timesing by it over here. Use your calculator and just round off to 1 decimal place and put your metres on the end of your answer. So I think we've done enough word problems on this. You can have a go at these yourself now. Good luck.